on to another session of Geography Practicals. We are going to look at enlargement and reduction. And well, I believe when we say enlargement, from the word enlarge means to make big, and then reduction from the word reduce, to make small. So that's basically with enlargement and reduction. And here there are some basic things you need to know in enlargement and reduction. One is the scale, scale factor, length, breadth. That is that. Another thing you should note is that apart from the scale factor, all the others with enlargement or reduction, you need two of each one of them. Meaning the scale, you need old and new. Length, likewise, old and new. Breadth, also old and new. Okay. On a given map, for instance, always there is the old scale. Okay, so here is the scale. This is in the RF, that's the representative fraction, and this is the linear scale. So this is your scale, and then your length, in case you are told to maybe reduce or enlarge the whole map outline, you start from here. Okay, if you are drawing the map outline, you don't start from the bigger box, no. You start from this where the actual map is. So you start from this line down here. So the whole dimension of this line. You start with you measure the inner line, not the outer line. Alright, so those are the things you need. So these ones, this is the old length, old width, and then the old scale. So let's look at each one of them one by one. We know that the scale is what the map is drawn in. That is the ratio of what is on the map to what is on the ground. And the old scale, as I said, is the original map, or we can say old scale or original scale. Either way is correct. So the old scale or the original scale is the scale the original map was drawn in. Okay, and then the scale factor. Scale factor is what you are going to enlarge or reduce the map by. That is the scale factor. So a scale factor of greater than 1. If the scale factor is greater than 1, that means enlargement. But if the scale factor is less than 1, reduction. Okay, so a scale factor of 2, 3, 4, 5, it's enlargement. That means you are going to enlarge. So in case they don't state it in the question that enlarge this place or reduce this place, and then they give you that draw a new outline map with a scale factor a number greater than 1, then you should know that you are going to enlarge the map. But in case they tell you to draw the new outline map by this scale factor, which is less than 1, so it could be 1/2, 1/3, 1/4, 1/5. Normally when it's reduction, the scale factor they give you is in fraction form, because 1/2 is the same as 0.5, which is less than 1. Okay, so that's for the scale factor. The length is the vertical form of the map you are going to enlarge or reduce. And likewise the width or the breadth. The width or the breadth is the horizontal sides of the map you are going to enlarge or reduce. Okay, so that is about that. Now, as I said, in each one you need old and then new. You need all 4 of these to draw a new outline map. And most often than not, all 4 might be given. But they don't give you both old and new. The old one represents the original map they gave you. And then the new one represents the one you are going to draw. That's why I said you need both old and then new. The old one is the one you are given, and then the new one is what you are going through. So assuming they give you a map of, say, the old map has a scope of 1:50,000. When you enlarge or reduce the map, this scale will change. So that new scale that you get, that becomes new scale. And then the scale factor is what you are going to enlarge or reduce the map by. So if it's a scale factor of 2, that means you're going to enlarge the map to 2 times its size. That means you're going to multiply everything by 2. If it's reduction by half, that means it's what? Over 2. 1/2. So you're going to multiply everything by 1/2. That is the scale factor. The length, the old length, say when you measure the length you had was, let's say, 17 centimeters. That is your old length. So the new map or the new outline map that you get, its length will then become the new length. So if there's 17 centimeters and you enlarged it to twice its size, it will be what? 17 times 2, giving us 34 centimeters. But then if you reduce it by 2, that is 1/2, you get 8.5 centimeters. So these ones now become your new length. The same thing for the breadth. If the breadth is, say, 12 centimeters, enlargement by 2 will give you 24, and the reduction by 2 will give you 6 centimeters. As simple as that. One will ask, how do we find these things out? We said there are formulas for everything. So the formula for finding the new scale is you multiply the old scale by the scale factor. As I said, everything is to be multiplied by the scale factor. You multiply the old scale by the scale factor. The same for the length. You multiply the old length by the scale factor. The same for the width. Old width by scale factor. As simple as that. But in case you are not given the scale factor, here you've been given the scale factor, so everything is good. We can move on from here. You don't need this. But then in case you are given the old length, the old scale and the new scale, and then you've been asked to determine whether the map has been enlarged or reduced, you need to find the scale factor first. So based on the scale factor, then you can determine whether the map has been enlarged or reduced. Now here's how to find the scale factor. You will just divide the new scale by the old scale. So these are the formulas. To do enlargement first, so we are going to enlarge it by 2. After that, we reduce it by 2. Okay, the question says that we should enlarge the area marked ABCD. So that's the area we're going to mark. Now here, 1, you've not been given the old length, the old breadth, but then you have the scale. You have the old scale, which is 1:50,000. That's your scale. So first thing we need, as I said, we need scale, length, breadth. The old scale we already have, which is 1:50,000. Now let's find the old length and then the old breadth, because it is with these things they are going to find the new ones. All right. So the old length, you measure any side, because we have about 8 centimeters. That's for the old length. So the old length, then let's see the old width or the old breadth, which is 8.1. Okay. 8.1 centimeters. Scale is old scale times scale factor. So that will mean that 1/50,000 times 2. So 2 goes here, 1. Okay, so that means that our new scale is 1:25,000. Don't forget, this is in the representative fraction form. So we can write it as a ratio or as a fraction. So 1/50,000 is the same as 1:50,000. And then the answer I got was 1/25,000. We wrote it as 1:25,000. This is the representative fraction scale. The next one is the length. So old length times scale factor is 8 times 2, giving us 16 centimeters. And then 8.1 times 2, giving us 2 times 1, 2, 2 times 8, 16. And then 1 decimal point, so giving us 16.2 centimeters. So these are our new dimensions. So for the new scale that you are going to draw. So please, when you are drawing the new outline, so these are the new dimensions for the new maps that we are going to draw. So please, when you are drawing the new outline, you follow the answers you've gotten. You will not just draw anything as you please. You have 16, so the length, you measure 16 centimeters and then you draw. The width, you measure 16 centimeters. From the board, we had the length to be 16 centimeters. So you draw 16 ends here. Okay. And then the width was 16.2. Okay, so after you are done drawing, you just label 16.2 centimeters, and then this side was 16 centimeters. And then you write your scale. Don't forget your scale. 1:25,000. And then you are done. But in case they told you that apart from drawing the scale, so apart from enlarging or reducing, you should draw some elements in it. Then you have to draw. So in case they tell you to draw all water bodies, you have to draw all the water bodies located within the map. So here we have a river. Let's see, we have 1, 2 tributaries of this river. So it flows to flow, and then they reach the dam here, forming a lake. Another one also comes, another tributary, another lake, and then it flows out. There is one here flowing from here and then coming here. So all of this you have to draw. I believe that is all the water bodies we can find. Yeah, so that is that. I was asked to give only the water bodies, and I've given only the water bodies. So depending on what you are asked to draw in the new map, the reduce and enlarge map, you draw. So that is that, and you should be done with enlargement. So now we are done with the enlargement and move to reduction. As I said, reduction, the scale factor is always less than 1. That is in fraction form. Simple as that. So this one we are reducing by half, which is 1/2. So what you do, you are going to multiply each and every one by 1/2 to get the mu of each one. So the scale 1:50,000 in fraction form to become what? 1/50,000 times 1/2. 1 times 1, 1. 2 times 50,000, giving us 100,000. Okay, so that's our new scale. 1/100,000, 1:100,000. And then our new length will be 8 times 1/2. 2 goes here, 1, 2 goes here, 4. Giving us 4 centimeters. And we have 8.1 times 1/2 give us 4.05 centimeters, which is almost close to 4.1. Okay, so now with the new dimensions, you draw the new outline map with the figures you have. You don't draw arbitrarily, as in anyhow. You draw with the figures. So length, you use the figure you have. You have 4.05. This 4 centimeters. That is what you use to draw. So let's go into our books and then quickly get the drawing done. So our length, we had 4 centimeters. So just draw up to 4 centimeters. Simple as that. The width was 4.05, which is almost close to 4.1. So 4.1, join. Simple as that. And 4 centimeters. Okay, so then you write your figures underneath 4.05 centimeters and then 4 centimeters, and then your scale 1:100,000. If you were asked to, let's say, insert some features or whatsoever, you do so. So let's say here, this is a footpath and you are asked to insert the footpath in the map. All you need to do is that you draw. So this is a footpath, another footpath. So you insert all of them. So starting from, look at the position. And then you are done. Please don't say that the sheet is big and then a small map, so I'm going to draw it to cover the sheet. No, it is not done. It is done as you've been instructed, and you've been instructed to reduce it. You don't expect something which has been reduced to be bigger than the old one. So here we've been given the old scale and then the new scale, but no scale factor. How are we supposed to draw the new dimensions without having a scale factor? This is where the formula comes in. You're going to divide this new scale by the old scale. The answer that you get is a scale factor. That's the formula for the final scale factor. So after you find the scale factor, then you come and then multiply with these two to get the new dimensions to draw the new map outline. So the formula says new scale divided by old scale. So the new scale is 1/25,000 divided by 1/15,000. So multiplication 1/25,000 times 50,000 over 1, which gives us 50,000 over 25,000. So 3 zeros goes here, 25 goes into itself, 1 goes here, 2, giving us 2/1, which is 2. So that means that the new scale factor is 2. Having found the scale factor, then we multiply to get our new dimensions and then we draw them in our book. Very, very simple. Thank you.